Good afternoon, good evening, and welcome to this webinar on how to ace GMAT Algebra. In this webinar, our focus specifically is on linear inequalities, absolute equations, and absolute inequalities. It's a fairly application-focused webinar. We start from the very fundamentals. We start from revising the very fundamentals, let me be very clear, and then we move on to 600 level questions and then 700 level questions. The focus is on applying the concepts. The focus is on demonstrating that if you know the basic concepts and if you have a unified way to approaching questions, you can solve the most challenging questions that the test will throw at you. Also, the focus is to on unearthing why you make a mistake and where you make a mistake. So in this webinar, if you want to make the most of it, I recommend you have a pen and paper ready because we will be solving about 15 questions in this webinar. So it'll be fairly fast paced. Now, to make sure that you have a base for this webinar, we did send a few video lessons your way. They were on linear inequalities in two variable, absolute inequalities, quadratic inequalities, and absolute equations. So if you've not watched these video lessons, they are a part of your free trial as you log into the e-GMAT account, and then you see the first list of about 25 odd video lessons that we have for you. They should be in the second group under the heading algebra. Okay, with that, we have a few free webinars as well. We have 2 free webinars next weekend. We have a free GMAT strategy webinar. How many of you over here need help creating a personalized study plan? Let's just get a yes/no poll over here. How many of you need help creating a personalized study plan? Select yes if you need help creating a personalized study plan. Select no if you already have a personalized study plan. All right, for those of you who need help in this webinar, the first webinar over here, which is this one, let me just put the arrow over here, which is this one over here, we talk about how do you go about creating a study plan that's optimized for you. Then we talk about how you go about executing that study plan, what skills should you learn, and how should you track as you put in every 20 hours of effort while learning that whether you're actually moving towards that target score of yours. So that's this webinar, and then next Sunday we have a proctored mock test. In this mock test, we actually evaluate your quant ability. And beyond that, we help you isolate your weaknesses, and we help you create a study plan which is personalized just for you with regards to GMAT quants. If you're someone who's studying, who's at Q43, want to get to a Q48, Q49, this will create that personalized path for you. If you're someone who's stuck at Q48 and able to get to a Q50, it'll tell you why you're faltering, where you're faltering, so that you can focus your energy over there. With that, let's kind of get to know this group as a whole. We have about 180 people over here, and let's kind of figure out where you guys are in quant as of today. So this poll says, what's your current quant score? And then let's just get in another poll question that talks about what's your target quant score. All right, let's get a few more responses over here. And these data points tell you how, I mean, we have about 170 students here in the webinar. These data points tell you how people think, what is it that people are thinking about, and where people are as they enter this webinar. So with regards to the current quant score, guys, I have 175 folks here. I'd prefer if I get at least 120 responses to the current quant score before I broadcast results. Again, this is, as I call it, a no-risk environment. I mean, you don't lose, we don't expose your identities over here. There's nothing that you have to prove. The reason why you are here is because you want to improve. So, if you're already at a Q50, I hope you don't attend this webinar because there are other productive places where you could be spending your energy. Okay, with regards to the current quant score, we have about 90% of the class in the less than Q30 to about a Q45 group over here, And then with regards to the target quant score, we have a good chunk of you who are in the Q, who want to who are aiming for a Q50, Q51. That's about 60% of you, or 62% of you, or so, give or take. And then the rest is kind of spread out across. With regards to when do you plan to take the test, about half of you have about more than 75 days. But then there's a significant number of you who are in a month to 45 days or so bracket. Again, I hope you're taking the GMAT, the online version of the GMAT, only because you have to take it in a month or 45 days. Otherwise, we don't recommend taking the test in a month to 45 days. We recommend that you wait till the test centers open. And then with regards to the target GMAT score, 730 to 750 is the most popular. And then about 23% of you are in the 710, 720 bucket, and about 18% of you are in the 760 plus bucket. That's good. Thank you very much, guys. With that, let's go right into the webinar pane. As I go there, the screen will have changed for you, or will be in the process of changing for you, and you'd see the presentation which says algebra. Below that, you'll see a Q&A pod or question and answer pod. If during the session, if you have any question, feel free to post that question in the Q&A pod. At this point, I think I should introduce my team over here. Supporting me in this webinar, actually, I should introduce myself. So good morning or good afternoon, good evening. My name is Raja Sadana. I'm one of the co-founders of e-GMAT, and I'm going to be your main host today. My apologies, I should have done that up front. And supporting me in this webinar, we have Ashutosh, who's a quant expert. He's also a GMAT strategy expert, and Lekhika. Lekhika is a part of our SEO team. She's also an excellent voice artist. If you saw the video on online GMAT on our YouTube channel, she's the one who recorded the script for that. And if you haven't, go look at it. It'll tell you everything that you need to know about the online version of the GMAT. Okay, with that, let's kind of move forward with this webinar, and I'm going to go all the way to the purpose of this session. Again, as I said earlier, I want to make sure that each one of you understands what it takes to solve 700 level questions successfully and consistently on the GMAT. And the takeaway that I want you guys to have is that, hey, if you know the basic concepts, if you follow a certain unified approach to solving questions, and if you are conscious of certain process skills, then acing GMAT quant is not about the math. It's about having that logical approach and then having those process skills in place. So everyone can ace it. Now, you guys are going to make mistakes while solving these questions, and I want you to not worry about those mistakes, but not repeat those mistakes. So as you make a mistake, take notes, and as you go from one question to the other, and the questions are designed very carefully in this webinar so that they build upon what you learned in the past. I want to make sure that you don't repeat those mistakes. So in terms of takeaways, write down the mistakes that you make so that as you practice questions post this webinar, you make sure that you don't make those mistakes. And which, by the way, would be the gaps in your preparation, and it'll point to where you should spend your energy to get to that 90th percentile in algebra. Okay, now how would this session progress? So we're going to focus on these concepts that are listed over here. We're going to do a warm-up quiz. This warm-up quiz contains very simple questions. All of these questions are problem-solving questions. The goal of this quiz is just to make sure that you know the core concepts. So I'm going to go through this quiz hopefully very quickly because you guys should know these concepts. If you don't know these concepts, or if you feel that you're fuzzy about applying this, go look at the lessons in the free trial. They'll help you not just up to these concepts, but even beyond those. And then from there on, we're going to apply these concepts in the context of GMAT. We're going to start with 600 to 700 level questions, and we're going to go from there to 700 level questions and even more challenging questions. Overall, we'll solve about 12 problem solving, 3 data sufficiency questions in this webinar. So as I said, about 15 questions overall. So with that, let's start with the warm-up section. you're only gonna get this is warm up, so I'm not gonna focus on giving you detailed solutions over here. This is stuff that you should already know. This is again to get your brain to exercise. So as we did yesterday, click on this thing called not solving because this is a warm up question. I don't want to time you guys, or in general, I won't like to time you guys in this webinar. I want this group to time itself. I have about 225 students here. So let's, I want at least 100 of you to click on still solving. That way, when 80% of you go from still solving to another response, I know as a group you guys are ready and I'll call time. Okay, I have 90 of you, 92, 95 of you've said still solving, 97, 100, perfect. Here is your first question. Okay, 80% of you are done. 5 seconds more. 3, 2, and 1. Let me end the poll. Most of you got this right, as you can really see. For those of you, amongst those of you who solved it, close to 80+% of you got it right. So that's good. It's a very simple question. Let's go to question number 2. Again, you guys know the drill. Let's select still solving. We're going to solve 3 questions in a group over here. And then we're going to analyze these 3 questions. Again, remember, these are warm-up questions. So simple questions. And the goal really is to get you guys ready for the real questions. 97 responses, 98, 100. Perfect. Here's your second question. That's 75% of you are done. So last 10 seconds, guys. Three, 2, and 1. Let me end the poll and broadcast the results. Again, you can see a majority of you got chose choice B, which I think is the correct one if I remember correctly, but we're going to analyze the first 3 questions after we're done with the third one. So again, let's go to still solving. Let's get to about 100 people saying still solving. 92, 95, 99, 100. Perfect. Here is your third question. All right, 80% of you are done. Let's get those responses in. 5, 4, 3, 2, and 1. Let me end the poll. Got 150 odd responses for this one. Let's broadcast results, and you can see this is more of a split jury. So we're going to really look at this. With that, let's just get to the first question. This is how you poll. Pretty much everyone got this right. The first question, fairly simple question. Choice B was the correct answer over here. What it says is, what's the range of values of y if this inequality exists, which is 4y plus 10 is greater than minus y. So how do you do that? You actually add add y to both sides, or you move minus y to the left, one way or the other. Essentially, this is what the inequality leads to. And what you do, you solve the inequality the regular way, and you get y is greater than minus 2. Okay, so essentially very simple operations on very simple operation on inequalities outside. I don't think there were multiple operations over here. And again, just to get your feet wet, and most of you did get this right. Again, if you have a basic knowledge of inequalities, you should have been able to solve this one. Let's go forward to question 2. Let me get in the poll for question 2. And so I'm not going to take any feedback for question 1, but question 2 is, I think, where um, a few of you made mistakes. Again, the answer was choice B, which is y is greater than minus 2. You have 2 inequalities given over here, and we are asked to find the range of values for y if these 2 inequalities hold true. What do? You actually take this first inequality, multiply it with 2, and why? Because you want to get to 2x over here, so that 2x and minus 2x get cancelled. So you do that, then you add those two inequalities. Um, as I said, 2x and minus 2x cancel each other out, and you essentially get y is greater than minus 2. So for those of you who made a mistake over here, because a few of you did, not many, but a few of you did uh, make a mistake. Why did you make a mistake? Let me just put in a short answer pod over here. Or where did you make a mistake? Because this is kind of the beginning of your takeaway to really say this is where I make mistakes. Those of you who chose choices either A, C, or D, or couldn't even solve this. Why and where did you make a mistake? Reverse the inequality, multiplied by minus 2 instead of 2, ended up getting confused with the signs. Okay. So one of the first things, so that's really good. One of the first things that you have to look at when it comes to inequalities is that can you do operations on the inequalities, which means do both the inequalities have the same sign? And in this case, you can really see both of them have the same sign. It's greater than over here as well as over here. And that's really important. And you can't solve the equation for x and Anjay, um, as you mentioned. All right. So again, you know where you're making mistakes over here. Now, here's question number 3. But in terms of what we tested in this is that, hey, if you have inequalities that have the same sign, which is this sign and this sign over here, you can add them, and essentially you're comfortable in solving two inequalities. You show your work, you don't make mistakes while doing basic operations. Again, if you made a mistake, write down where you made a mistake so that you don't repeat it. Let's go to the third question. Third question, many of you actually made mistakes. So what are we asking about? We're saying how many non-negative integral values. What are non-negative integral values? What are non-negative integral values? Values that are greater than 0. They're including 0, actually 0, 1, 2, 3, because 0 is also non-negative. Okay. If you're unable to see the PPT, that one person who's unable to see the PPT, just join again. The problem will sort out by itself. Okay. 0 is included in non-negative, and 0 is also included in non-positive. 0 is kind of that neutral thing over here. So what do? You add both the inequalities. When you do that, your n gets cancelled and you get minus 4m is greater than minus 10. Now remember, there's negative on both sides, which means if you multiply both sides by minus 1, you'd be making a mistake. You can't do that without changing the sign of inequality. So you multiply both sides by minus 1 and you change the sign of inequality. I want to emphasize on this part over here. Here the sign is greater than. Once you multiply it by minus 1, this became less than, which is, if you do the math, you really multiply both sides or divide both sides by 4, you get m is less than 10 by 4, which means m is less than 2.5, which means there are 3 values, which is 0, 1, and 2, that are non-negative values of m that satisfy both these inequalities. Now, only 30% of you chose choice C. The other 70%, where did you make a mistake? Forgot about 0. Okay, didn't consider 0. Those are folks who chose choice B, and I understand that. What about people who chose choice A? Okay, always remember two concepts. One is if inequalities have the same sign, which they do over here, you can add them. And the second thing is the sign of an inequality changes when you multiply it with a negative number. This is a concept we're going to use again and again in this webinar. So please remember this over here. Okay, there are two reasons why people made a mistake. One is they did not reverse the sign. The second is they did not consider 0. Again, good takeaways over here. Now, that's good. Let's go to question number 4. Let me just put in the poll for question number 4, and you guys know the drill. Select still solving. Perfect. Let me remove broadcast results. Here is your question number. Almost 80% of you are done. Let's get those answers in. 3, 2, and 1. Let me end the poll and broadcast the results. So choices A and C are very popular, as you guys can see. We're going to discuss 4 and 5 together. So let's do question number 5 as question 5. Let's select still solving. All right. You guys are getting better at this. 90 of you have selected still solving. 100 of you. Here is your 5th question. All right, 80% of you done. Let's get those answers in. 3, 2, and 1. Let me end the poll. Broadcast the results. Again, more confusion over here. So let's kind of move forward. So we kind of moved over from inequalities in just linear inequalities into variables to just finding the range of inequalities where you have a product of two numbers. And what this one really says is, what's the range of inequality? A product of two numbers is positive. So first thing, whenever you read a mathematical equation, especially in absolute values inequalities, try and frame it in English. As you do that, you're going to find that life becomes easier. And the way I read this is, hey, it's a product of two numbers. Both these numbers can be either positive or negative, and that product has to be positive. It has to be greater than 0. So greater than 0, read it as positive. If it's equal to 0 and greater, then you say 0 or positive. Again, start using those terms in your mind, and then you're going to actually make fewer mistakes. So product of two numbers, both numbers can be positive or negative, has to be positive. So when can a product of two numbers be positive? First, when both of them are positive. Second, when both of them are negative. Okay, that's simple, right? So far, it's all logic, really no math till now. Correct? All right, thank you. Most of you got this. Pretty much everyone got this. So when are both of them positive? When x is greater than 3. Why? Because x is greater than 3 is the stricter constraint over here. When are both of them negative? When x is less than 2. Okay, that's when, because that's a stricter constraint. So giving a combining this, we really get choice C, where it's 3 to plus infinity and 2 to minus infinity, where both 3 and 2 are excluded from this. Now, many of you got this right, but many of you also made a mistake over here. Why and where did you make a mistake? Why and where did you make a mistake? Okay, in combining. Did not translate it to English. That's something which you have to always do. In fact, this is a really important core skill called translate, which we teach. Okay, let me ask this one question as you're doing this. How many of you are subscribed to our YouTube channel? How many of you are YouTube subscribers or subscribers to our YouTube channel? Yay versus nay. Okay, the question yes versus no is how many of you are have subscribed to our YouTube channel? Okay, about 50% of you, give or take here. If you haven't, do subscribe to our YouTube channel. Why? Because all these core skills that we talk about over here, they are in elaborate lessons. So we've actually created skill-based videos on our YouTube channel. These are free of charge, available to everyone, and you guys can learn from this. There are about 17 videos, and we're going to add another 15 over there. So here is the link to the YouTube channel. Here's a link to those videos, by the way, and which you can get to, but over here, and I'm going to share the link to our YouTube channel as well. And this should have come as a clickable link. The year 2019 was okay, that was an auto video, a video that played automatically, but here is the link to the channel which you can subscribe to. It will be, but these are specifically created videos that are only on our YouTube channel. They'll go on our course very soon. And you know, more than 10,000 people, actually more than 1,000 people have viewed them, and they've consumed over 100,000 minutes on the channel already. in the last 20 or so days. Okay, perfect. That is great. Let's move forward. This was question number 4, and apologies for the break. We're now at question number 5. Question number 5 was slightly interesting. But again, what is the concept that was tested over here? No new concept. Essentially, the concept that we tested was a number properties concept, where a product of two numbers is positive when either both of them are positive or both of them are negative. When one of them is positive and the other one is negative, then the product is negative. Okay. Again, we can do it using a wavy line method. I mean, if you're comfortable with this, you can do this. We also teach this method in our course. If you're not, you can also use the fundamental approach. Now, this one was a slightly tricky one. You're given a fraction, and you said this is a purely in terms of translating this to English. What you have to really say is, hey, you're given two numbers, a by b, and you said this fraction is negative, which means because x minus 3 and x plus 4 both could be either positive or negative, and what we are asked is what is the range of values of x for which this fraction could be negative. So that's something that we are asked to do. Now, we don't like fractions. It's difficult doing operations on fractions. So one way to get rid of fractions is multiply both sides, because on the right hand side you have 0, so anything multiplied with 0 is 0. You multiply both sides with x plus 4. If you did that, you would be incorrect. Why? Because x plus 4 as an entity could be both positive or negative, which means you won't know whether to change the sign of inequality or not. Why? Because if it's negative, you multiply a negative number on both sides, you've got to change the sign. If it's positive, you don't need to change the sign. So we can't multiply on both sides by x plus 4 to kill the fraction. But we can multiply by x plus 4 whole square. Why? Because the square of a number in the world of in real numbers, which is what the GMAT world is always positive. So remember this, square of a number always positive in the world that we live in. Okay. So what we do is we do exactly that. We multiply both sides by x plus 4 whole square. Again, right hand side is 0. So nothing changes over there. The denominator gets cancelled and you get this as x plus 4 multiplied by x minus 3 is negative. It's a product of two numbers and the product of two numbers is negative. Now, we pretty much operate the way we did in the previous question. We actually either use the wavy line method, or we really say, hey, the product of two numbers is negative when one of them is positive and the other one is negative. Either way, you would get to this answer. So only 47% of you got it right. Where did you make a mistake over here? Where did you guys make a mistake? Did not square and multiply. Silly calculation mistake. Okay. Again, don't call it silly. Say you have a problem doing the calculation. You're probably not showing your work. Again, the problem with me calling anything a silly mistake is there's no remedial action to that silly mistake. But if you really say it's a calculation mistake, then the next step is I'm going to show my work more clearly. I'm going to be more methodical. I'm going to actually show more steps. So I don't call it a careless mistake. Specify the mistake that you have that you've made, and then tell yourself what remedial action would you do. Okay, that's great. With that, let's go to the last warm-up question for the day, and then we're going to start doing more fun questions. You guys know the drill. Click on still solving. Okay, 89 people. I want to get 100 people to say still solving. Yes, we have 100 people. Let me show the question to you. Here is the last question for the All right, 80% of you done. Let's get those answers in. 3, 2, and 1. Let me end the poll. All right, most of you got this right. So I'm going to go through this fairly quickly. You're given um, an absolute value, and you're really saying, hey, which of the following inequalities is equivalent to this absolute value of which is x plus 3 is less than or equal to 5. So how do you go about doing this? The answer is choice C. Most of you got this right. So you really say, hey, let's substitute x plus 3 as z, which means absolute value of z is less than or equal to 5. Because it's less than or equal to 5, not greater than, remember this. You can only do this for less than or equal to 5. You actually go to the fundamentals of absolute value and you visualize them on a number line. What you really say is there are 11 possible values starting from -5 to +5. Now again, remember how I'm translating everything to English over here. And when you do that, you actually infer additional things such as, hey, there are 11 possible values, zeros included. They go from -5 to +5. The more you start doing that, the faster you're going to solve questions, and the fewer is going to be the number of mistakes. So then you really say, okay, hey, z is between -5 and +5, both included. Then let's replace z by x plus 3. And you do the math and you really get x is between -8 and +2. So the span is still 11, -8 to +2. It just is shifted by 3 values towards the left. Okay. Again, the key piece over here is that, hey, you're interpreting absolute value as the distance between 2 points when it is less than or equal to. That's really important over here. Now, with this, we're done with the warm-up set. The goal over here was to make sure that you guys have clarity on a few basic concepts before we move forward. If you've made a mistake, go revise the files. You do need help over there. And because now as we move forward, we're going to start having a bit more fun. So with that, and now we're going to do one question at a time. So it's not going to be warm up, but it's going to be one question at a time. So let's go to still solving. And let's get 100 of you to select still solving. And by the way, these are the concepts that you have in the free trial. Okay. This is just one module within algebra. This is not the entire algebra course. This is just module 8 over here within algebra. As you can really see, it says module 8, inequalities and absolute value equations. And we have these as a part of your free trial. Okay, so make sure you do that. Okay. 100 people. I still have 98. Can we get 2 more, please? Who say still solving? Perfect. Here is your first 600 level question. 85% of you are done. Let's get those responses in. 3, 2, and 1. Let's end the poll. I'm going to broadcast the results. Hey, you can see most of you did it right, actually. About 70% of you did it right, because a good chunk of you, or about 9% of you, are still in the still solving phase. So let's see how we go about doing this. So you're given an inequality in a single variable, that's x, and what we're asked is, what's the range of x given this inequality? Now, even before you start solving, the first thing that you have to do is figure out, are there any constraints? And you read the question stem again, you actually see there are no constraints over there. So you're given this inequality, you've got to find the range of x. Now, again, focus on how I'm approaching this, not the math piece, but first of all, I'm checking if there are any constraints, whether explicit or implicit. And this is another process skill that we talk about on those videos, which is applying constraints, or first of all, figuring out constraints. And then we're looking at what is it that we need to do. So you rearrange the terms, you actually get all the terms with x on one side, all the numerical terms on the other side. Remember, we've still not changed the sign of inequality. This is the same as the greater than sign over here that you have over here. Then you really get to, if you do the math, minus 32x is greater than 64. How many of you were able to get to this point? How many of you were able to get here, till this point over here? 97% of you were able to get that. So 97% of you should have gotten this right, by the way. When you multiply with -1 on both sides, you could make a mistake. That's a potential thing. That's just testing. If you don't change the sign of inequality, what starts to happen is you get 32x is greater than -64, and you get to x greater than -2, which is what leads to the wrong result, which is where you would have chosen either choice A or choice B, and about 10% of you chose choice B. Okay. The correct answer is choice C. But if you did not change the sign of inequality, you would have chosen either choice A or B. Why? Because you would have gone down this path. But the right way to do it is to change the sign of inequality. Again, let me emphasize over here. Here you have a greater than sign, and here you have a less than sign. Why? Because you multiplied with -1 on both sides. And as you did that, you then divided by plus 32. And remember how I'm saying plus 32 explicitly, which means you don't have to change the sign, and you get x is less than -2. When you say x is less than -2, you say x is between -2 and minus infinity. Okay. Now, a lot of you made a mistake. 40% of you made a mistake. Why did you make a mistake? Why did you make a mistake? Forgot the negative. And you can really see how and why people make a mistake. And you can see commonalities over here. Press the wrong button, okay? Forgot. Again, check the answer. Look at what you've done over here, what you've written on your scratch pad versus what is it that you're marking. Chose the option with 2 again. Right? Sound the options in your mind before you look at the options. So when you're doing the math, it's like, for those of you who attended the pre-thinking session yesterday. How many of you attended the pre-thinking session yesterday? Let's get a yay or a nay over here. Okay, given the stats that are pouring in, about half of you did. As I mentioned yesterday, for those of you who attended the critical reasoning session, when you do pre-thinking, you sound it in your mind. Options don't confuse you as much. Do the same thing in math. Why should you not do the same thing? Okay. Again, if you have a question, you can put it in the Q&A part. But again, understand why you made a mistake and don't make that mistake again. We're going to go to the next question. The next question is going to go a couple of steps further. Same concepts, but a couple of steps further. So take these learnings over here. But before I show the next question, I want you to mark still solving. All right, I have 100 people who marked still solving. Here is your next question. Good luck. All right, you guys are done. Let's get those answers in. 3, 2, and 1. Let me end the poll. Broadcast the results. Oops. I'm sorry. Can you guys put the results in again? Somehow something happened. And I do remember the stats. So, all right. 3, 2, and 1. And my apologies. I thoroughly apologize, guys. And 1. We end the. I'm sorry. Something strange is happening. The system's not behaving properly. I'm not going to end the poll. I'm just going to broadcast the results. I want you guys to select the results once again. My apologies, guys. I'm not sure why this is happening. 3, 2, and 1. So let me broadcast the results. And about 85% of you chose either choices A or B. The correct answer we're going to really look at as what it is. But 85% or 87% of you, given the stats over here, should have gotten this question right, even though this is a difficult question. So let's kind of look at how we're going to solve this question, because 87% of you were on the right path to solving this and did the math right but did not do the English right. Okay, so what's given to us? Choice B is the correct answer. You can really see it over here, and what you're given inequalities in one variable, and then you're asked as to what's the minimum value of integer x for if both these inequalities. Yeah, so now you guys are realizing minus 5.5 is not an integer. Okay, so why did you fail? Was it the math that you guys failed? Did the math fail you? No, the math didn't fail you. It was the English. It was the process. Uh, and that's where you say it's really important to follow this process. You say, hey, what's given to me? What do I have to find? And is there an implicit or an explicit constraint? Here, in this case, this is an explicit constraint. Again, one of the process skills that we talk about, always apply constraints. Not a careless mistake. It is a gap in how you approach questions. You don't look for constraints. What is the level of this question? So according to us as experts, this is a 600 level question, but according to the stats that we see over here, this is a 700 level question. Why? Because only 35% of the 170 odd attempts that we had on this question, 35% of the folks got it right. And this is what makes a fairly medium difficulty question a hard question. It's not the math, it's the fact that you have these other things where you're not applying the constraint. Okay, so how do you go about doing this? You solve each inequality separately. The first one tells you that x has to be greater than or equal to minus 5.5. The second one you already knew was x is less than minus 2. So minus 2 is not included, minus 5.5 is included, and you say, okay, what's the smallest value of an integer x? That's minus 5, which is where you get to this point over here. Now, a few of you chose minus 2. Those of you who chose minus 2 over here, you guys actually found the greatest value, and which again is minus 3, not minus 2 overall. Okay. Now, we're going to solve another question, a very interesting question coming up, and we're starting to have fun now. Let's kind of make sure that you guys select still solving. Does the GMAT have redundant answer choices? I don't know which answer choice are you calling as redundant, but yes, if you have minus 5.5 and minus 5, the GMAT definitely will have both. Why? Because you can see the number of people who chose minus 5.5. Okay, I need 100 people to say still solving, guys, before I show the next question, because I think you're ready for the next question. All right, 3, 2, and 1. So take all the learnings from this question and apply to the next one. The next one requires very little math, by the way. Okay, I'm giving you a hint. All right, 3, 2, 1. Here is your 70% of you are done. Let's get those answers in. Three, two, and one. Let me end the poll. Okay. Let me just end the poll. Man, this is still happening, guys. Get those answers and I'm not going to end the poll. I'm going to broadcast the results directly. I'm going to actually take a screenshot. That way I have the stats so that you guys can't change your results. All right, let's get those results once again. My apologies for making you do the extra work. Yeah, it's just, I hate when technology doesn't work. For those of you who've seen my interviews, I love technology and I love solving problems at scale using technology. So when it doesn't work, I get into that mode where it takes my focus away to a certain degree many a times, but because I want technology to work for the betterment of all of us. So 3, 2, and 1. Let's broadcast the results. What you see over here is choices A and D are really popular over here. Most of you have either moved towards choice A or choice D, which means you did the math right, you didn't do the English right. Let's kind of look at which one is the correct answer. So, what is the question asking you? Again, familiar mistakes. People go and start solving questions right away. What is this question asking you? Values of z square, okay? If z is actually, hold on. We should do another one. We have two questions, one after the other, so sorry about that. We're going to solve another question, then we're going to discuss both of them together. Here is the next question that you're going to solve. My bad. Over here, I'm going to remove broadcast results. Here is the next question for you to solve. And then we're going to discuss both these questions together. Most of you are done. 3, 2, and 1. And let me broadcast the results. For the second one, choice C is the most popular choice. So let's kind of look at it. Here are your responses to the first one. Choices A and D are really popular. Let's go to the first one. The first one says, what's the range of values of z square given this product? So one of the things which is there is you've got to ask yourself, what are we asking? And we are not asking for the values of z, we're asking for the values of z square. How many of you noticed that or observed that when you were solving this question? Okay, yes versus no. All right, most of you did that. That's wonderful. I'm happy to see that. Okay, so we have to find the range of values of z square given the fact that this product is negative. Less than 0 means negative. Then If you focus on finding the values of z, you would have gotten to choice E, and which is where you would have made a mistake, and a few of you actually did make a mistake. Then you've got to solve this inequality. Constraint, there's an implied constraint here that a square of a number is always non-negative. It could be 0, it could be positive, but it's always non-negative. How many of you have observed that constraint? How many of you observe that constraint that a square of a number is always positive? Why? Because the world of GMAT exists. In the world of GMAT, you only have real numbers, and real numbers, the square of it is always positive. Let's get a yes no pod just to make sure that you did this. And again, be honest with yourself. As I said, this is a fairly low risk environment. So how many of you observed this constraint? The square of a number is always non-negative. It's either 0 or positive. 60% of you observe this constraint. That's, if you did not, please, make sure you write it down that a square of a number in the context of the GMAT is non-negative. There are no imaginary numbers in the context of the GMAT. For those of you who don't know what imaginary numbers are, even better, you don't even need to be burdened by it. For those of you who know it, just tell yourself, in the world of GMAT, there are no imaginary numbers. So, but 40% of you faltered over here. And again, you can really see where you're faltering. You weren't able to get an implied constraint. Okay. So, because z square is always positive, we know z square plus 4 is also always positive. Why? Because 4 is positive, z square is positive. Sum of two positive numbers is always positive. Okay. So, z square is 0 or positive and 4 is positive. So, essentially what this results in is z square minus 2 is negative, which means z square is less than 2, which means the range is 0 greater than equal to z square, and z square being less than 2. For those of you who made a mistake, and about 60% of you made a mistake, where did you make a mistake? What do you want me to repeat? And again, when you said z square is less than 2, you remember z square, the smallest value can be 0, and which is where you say 0 greater than equal to z square less than 2. Okay, I'll explain it again. So because this term is always positive, so let's kind of read the expression. The expression is product of two numbers is negative. Now, one thing as you put in your inference skills, you figured out that, hey, z square plus 4 is always positive, which means z square minus 2 is negative, which is kind of what we kind of learn from the warm-up questions. The product of two numbers is always is negative, then one of them has to be positive, the other one has to be negative, and we know this number over here is positive, which means this number is positive, which means this number over here, z square minus 2, has to be negative, which is what we have over here. If z square minus 2 is negative, which means less than 0, then we get z square is less than 2. Now, the smallest possible value of a square of a number, again, another implied constraint, is 0, which means you put 0 on the left-hand side and 2 on the right-hand side, and you have the equal to or greater than sign over here. Is this clear? Is this clear? Yes, no? All right, perfect. So again, it's not the math that's faltering you, it's the logic piece. Now, let's go to the next question. And I'm going to put this over here. I'm going to show your responses. 50% of you got this right, or 54% of you. Choice C, I think, is the correct answer, if I remember correctly. What does the question ask? And what does the question tell you? What is it asking? What the question is asking is, how many values of z square satisfy this inequality? And what does it tell you? It tells you that z is an integer. Okay. So how do you go about doing this? From the prior question, you got Z square is between 0 and 2, which means since Z is an integer, Z square is also an integer, which means 0, Z square could be 0 or 1. Okay. Now, for those of you who chose 3, you also took the value of Z as minus 1, which again, there are 3 possible values of Z, but when Z is minus 1, Z square is still 1. Okay. If Z is minus 1, Z square is still 1. And that's kind of where you faltered. You had to find out the number of values of Z square. Finley, does that help you as to figure out? I mean, you did the math right, you just didn't do the English right or didn't do the logic right. You figure out 0 minus 1 plus 1, that's really good. Those are 3 possible values of Z, but the possible values of Z square that it results in are 0 and 1, which means there are 2 values, which makes choice C as the correct answer. All right. Are we starting to have fun now? All right. Okay. And again, one of the things that you're starting to realize is, hey, the math part is easy, right? The math part is not as difficult. It's the other things that make this that make this more complex. And those other things are not that difficult, frankly. Okay, it's not the math, it's the English and logic. So let's do that. We're done with the 600 level questions. Now we're going to start with the 700 level questions. But the takeaways over here are, hey, in the first question, just the basic concepts. That's what we learned. Okay, and the only concept that we applied was when you change the sign of inequality when you multiply it with a negative number. Perfect square is always not negative is something that we figured out in questions 3 and 4. We did use the wavy line method, although we didn't need to. We could have used logic as well. The skill of simplifying an equation to bring it to a known form. You could have used z square as k as a skill of simplifying, and you could have done that as well, and with the constraint that k is 0 or positive. And again, throughout the 600 level questions, you had to focus on constraints. Okay. Now, we're going to start solving 700 level questions now. And so I want you to select still solving again, because these are 700 level questions. It's best if I don't constrain you or if I don't time you guys. And as we go to 700 level questions, what you're going to realize is, the questions become slightly more laborious, which means you've got to show your work a bit more. But it's not that the concept that they're testing are uber complex. It's just that they want you to be a bit more methodical. They don't want you to give up when you're solving something. Okay. So if you don't have a pen and paper yet, if you don't have a clean sheet of paper, please get one. And by the way, for those of you who are contemplating an online GMAT, you can really see as you get to 700 level questions, it's going to be really difficult to do any of this and on the whiteboard that they're going to provide. So if you're contemplating the online version of GMAT, I would recommend think again till they don't change the format or till they don't allow the whiteboard. Okay. So with that, here are 700 level questions. Here is your first question. All right, guys. 73% of you are done. Let's get those answers in. 5, 4, 3, 2, and 1. Perfect. I'm not going to end the poll because I might risk messing it up. I'm going to broadcast the results right away so you can really see how you guys did. You can see 12% of you still haven't submitted an answer, but choice E is the most popular, and then you have choices B, C, and D as fairly popular as well. So we're going to go about doing this. Now, so one of the things that you notice is the question statement's pretty long. I mean, there's a lot of information in the question statement. So the first thing that you read, and that's why you need to read slowly, and it tells you x and y are positive integers such that, so first you say, okay, there's a constraint, x and y positive integers, such that the first inequality has a greater than sign, the second inequality has a less than sign. So x plus 2y is greater than 20, and 3x minus 30 is greater than minus y. Then the author asks you to find out the positive difference between the minimum possible value of x and the minimum possible value of y. This statement, very dense. For those of you who did not spend about 30 seconds reading the question stem and writing the constraints down, there's a very high likelihood that you will answer this question incorrectly despite doing the math. So how do you go about doing this? You actually write down the two inequalities, and you really notice the fact that they don't have the same sign, which means you have to do some processing before you can do operations on them. Then we've got to find the positive difference between the minimum value of x and the minimum value of y. And then the constraint is x and y are positive integers. Okay, they're positive and they are integers. There are two constraints in there. So the first thing you do is you actually express these inequalities in standard form. Then you solve them, and then you actually apply the constraints to find the answer. So to express the inequalities in standard form, you take each inequality and you express it as ax plus by plus c is greater than 0. You can really see how we've done that to inequality 1 as well as to inequality 2 over here. Okay. Now remember, as we did this over here, we actually multiplied inequality 2 by minus 1 at this point. So now you have both these inequalities in standard form. Now we can do operations on them, and to solve them, we actually multiply 1 okay, Satakshi, please put your question in the Q&A pod. I would recommend that you do that. Okay. Uh, as you multiply 1 by 3, you get 3x plus 6y minus 60 is greater than 0, and you actually put 2 over here and you call it 4. Okay, and what you really see is you can now cancel minus 3x out, and as you add by adding these inequalities, you get 5y minus 30 is positive, which means y minus 6 is positive, which means y is greater than 6. How many of you were able to get to this point? We just put in a yes no poll over here. And that's kind of where stats show up. How many of you were able to get to this point? This is a very stark contrast. 80% of you did the math right. Only 35% of you got the question right. So that's kind of what the difference between focusing on these process skills versus not focusing on these process skills is. It's not the math again. It's the process skills. Okay. Now similarly, so you got this y minus 6 is greater than 0. You name this 5, and you had this term over here, number 2, where you had minus y. You add both of them, you actually get minus 3x plus 24 is positive, which means minus x is greater than minus 8, or x is less than 8. Okay, though that's your second inequality, or solved inequality, or second set of constraints. So then you really say if x has to be less than 8 and y has to be greater than 6, and we know that x and y are positive integers, which means the minimum value of x is 1 and the minimum value of y is 7, then what's the positive difference between the minimum value of x and the minimum value of y? The positive difference is 7 minus 1, that is plus 6. If you chose choice A, which very few of you have done, I'm very happy with that. Then you actually didn't look at the positive difference over here, this term, uh, essentially. But uh, if you chose any other answer, for example, if you took, if you actually chose choice B, which is about 13% if you've chosen choice B, then uh, in that case, you took the maximum value of x and the minimum value of y, so 7 minus 7, and that's what leads to 0. Greater than 0 for inequality 2, uh, which one? Yeah, took the max value of x. Okay, why you were able to change 7 minus 7? Okay, change to greater than 0 for it, because x and y are positive integers as given in the question statement, which means if x is less than 8, then minimum value of x is 1. Okay, remember x and y are positive integers. Does that help? Because x and y are positive integers and we are told that x is less than 8, which means the smallest possible value, smallest possible integral value of x that is positive is 1. Okay, 0 is not a positive integer. 0 is a neutral integer. It comes in non-negative and non-positives both. Okay, 0 is not positive or negative. Y minus 3x plus 24. This is how you get if you add 5, which is over here, and 2, you do the math, you get there. Now, if you solved it another way, that's okay too, as long as you got to x is less than 8. Okay, as long as you got to this. But if you did not get to this, then you actually made a mistake in the math. Why are we adding 5 and 2? Because we want to solve for x. There are but 4 other ways to solve for x, so you don't necessarily need to do it. Okay, but this was an easier way for me. Okay, so why did you make a mistake? Let's kind of write those answers down, please. Can you please solve for x using inequality 1? No, I'm not going to do that over here, guys. Um, but I've done that, and I'll tell you, you'll get the same answer if you do it right. So if you're getting a different answer, then essentially there's somewhere where you're making a mistake. Change inequality, okay, changing the sign, calculation mistake, didn't apply the constraints properly, okay, you did not change the sign of inequality, took x as 7 and not x as 1, okay. So now you're really seeing, what makes this a 700 level question is that it's still not the math, A few of you actually faltered in the math, but many of you faltered with regards to did not change the sign of inequality, or with regards to the fact that you did not convert the inequalities to standard form, or you did not apply the constraints. And here there were many constraints uh, that you need to apply. Okay. If you use 5 and 1, trust me, you will get the same answer. Okay, you'll get x less than 8. Solve it again, please. Approve. Solve it again because we've done that. So if you're getting x greater than 8, you're making a calculation mistake. I'm telling you that. And again, so solve it again, and you're going to get that. I'm not going to solve this question. This is a scary looking question. It's only if you are at a Q51 level, you're going to get this. We're now going to go to absolute value questions, and we're going to have more fun over here. Okay. We're going to go to absolute value questions. We're going to start solving data sufficiency questions over here. So absolute value questions, I'm going to clear all responses. Now, as we solve these questions, a lot of these questions are not about the math. So you can, first of all, yeah, still solving. I appreciate that, those of you doing it. Let's get to 100 responses on still solving. But as you get to these absolute value questions, I want you to take a step back and do a few things. One is make sure you read the statement and draw all the inferences out of it. When you get to data sufficiency questions, process skills start to become even more important. And which process skills? The ability to understand and apply constraints, the ability to draw inferences, the ability to consider all cases. All of these process skills start to become a lot more uh, uh, a lot more important. Now, the other nice thing about data sufficiency questions is if you have those process skills, if you apply those process skills, the math is actually fairly trivial in most of them. So guys, 25 more people saying still solving. Can we get that, please? I have 77 people saying still solving. 84, 88, 92, 96, 98, 99. One more person saying still solving. Good. Here is your first question. Again, go slow, please. And you're going to find you can solve this in a minute. If you go fast, you're going to take 3 minutes and still make a mistake. Here is the question. All right, 70% of you are done. Let's give you another 30 seconds. Five, four, three, two, and one. Let's broadcast the results. Choice E, surprisingly, is the most popular choice where people say, man, this is not sufficient. And choice E is actually not the correct answer. Let's kind of really see how we go about doing this. This is a 600 level question, but the stats show that this is a 700 level question for this group. Let's go about this. What's the question asking? Is Z positive? And this is really important to know. What it's asking is Z. What does it mean when you say is Z positive? What does it mean when you say is Z positive? Is it greater than 0? Yes. Is Z greater than 0? And is there a constraint? Yes, there is a constraint. Z is an integer, so Z can't take any decimal or fractional values. And the other constraint that's given to us is that absolute value of Z is less than 6. Now, when you look at this, you really say, again, remember, always read it as if you're reading an English statement. What it means is that Z is between plus 6 and minus 6. And because Z is an integer, it could have 11 possible values ranging from minus 5 to plus 5. These are all the inferences that we are drawing and the constraints that we are applying from the original question statement. How many of you did that? How many of you drew these inferences from these question statements? There are 11 possible values of Z ranging from plus 5 to minus 5. Z can only be an integer, and we have to figure out whether the values of Z, possible values of Z, are in 1 to 5. Okay. Actually, let's get a yes no poll. Yes no poll is much better with regards to representative data. The question is, how many of you kind of inferred everything before you even started looking at the question statements? You've got to figure out, can Z between plus 1 and plus 5. 80% of you did that, yet only 22% of you or 23% of you got the correct answer, if I remember the correct answer. So let's kind of take a look at this over here. Okay, let's look at the first statement. We have to figure out, is Z positive? Okay, so the first statement says absolute value of Z minus 2 is greater than 3. Okay, that's what it's saying. Absolute value of Z minus 2 is greater than 3. Now, we can't write, remember, because of the sign greater than, we can't write it like this. What we can really do is we can substitute t as z minus 2 as t, and we can really say t is greater than 3, which means t is either less than minus 3 or t is greater than 3. Remember, minus 3 and 3 are both not included, which is why you have the empty points over there. So when z minus 2 is greater than 3, how you can really write this down is, you can say z minus 2 is greater than 3 or z minus 2 is less than minus 3. Again, we get this piece from here, less than minus 3, greater than 3, we get this thing from here. You start solving for both of them. You get z is greater than 5. Now, how many of you figured out z is greater than 5? How many of you were able to get to z to be greater than 5? Let's get a few more responses. How many of you were able to get to z is greater than 5? 67 of you, or 82% of you, were able to get to it. Yet, you made a mistake, which is very strange. And I want to figure out where you made a mistake. So z is greater than 5 or z is less than -1. How many of you were able to figure out z is less than -1? And again, if you look at the operations that we're doing, we've done each of these operations, each of these transformations in the warm-up questions. So there's nothing new that we're doing. It's just that we are combining more things here. 73% of you were able to figure this out. Okay. So given the constraints that we had in the original question stem, given that z is an integer between an absolute value of z is less than 6, is this even a possibility? Is this even a possibility? Let me just clear all answers. No, it's not a possibility. It's not a possibility because what we know from the constraints is z has to be between +5 and -5, and there's no value of z if you apply these constraints that z is greater than 5. Okay, so because there's no integral value between 5 and 6, and z is also an integer, we say, hey, all values of z are negative. Then can we answer this question over here that we have to ask, is z positive with statement A? Absolutely, yes. We can say, yes, z is not positive. We are 100% certain that z is not positive. Why? Because all values of z are negative. And we know that positive and negative are mutually exclusive, which means statement A or statement 1 is sufficient. Okay. Where did you guys make a mistake with regards to statement 1? We're going to go to statement 2, but where did you make a mistake with regards to statement 1? Are we required to get a specific answer in the question there? Are we required to get a specific answer? No. Okay, converting absolute value of inequality. You ended up solving for z. You did not focus on what is it that the question was asking. The question is merely asking, is z positive? Okay. Okay, now you're seeing where you're making a mistake. Let's go to statement 2 right now. Statement 2 says, statement 2 is actually fairly simple. Absolute value of z is equal to 2. What does this mean? It means z can have two values, +2 and -2. When we independently take statement 2, both of these values are amongst the 11 values that z can take, which means we cannot say with 100% certainty whether z is positive, which means statement 2 is not sufficient, which means choice A is the correct answer. Okay. So what are your takeaways from this? What are your takeaways from this? Read carefully. Could you please explain statement 2? Yeah, absolute value of z is equal to 2, which means z could either take +2 or -2. That's kind of the very definition of absolute value. Okay. So z could be +2 or -2, which means it could have two values. Now both +2 and -2, remember when we analyzed the question statement, were possible values because they were amongst the 11 possible values between -5 and +5, which means we cannot answer this question, is z positive with 100% certainty. Why? Because it could either be +2 or it could be -2. Read the question carefully. All right, that is good. Careless mistakes. DS also requires scratch paper. Okay. As I said earlier, please make sure you have this. Specifics are not required. We can have a range of answers as long as they fit the question asked. That is good. Okay, we are now going to go to the next question. And again, I'm going to share the PDF with you. If you still have doubt about the math, you're going to have the PDF. Can you guys still select still solving? We're going to do the next question, which may seem like a fairly confusing question, but it's a very fundamentals based question. It's a beautifully designed question. So let's kind of look at this. So absolute value questions are a lot of fun. And there are a lot of English than a lot of math. So let's get to this. Let's get to at least 80 of you saying still solving. 80 people saying still solving. 66, 68. All right, I have more than 80. That's wonderful. I'm going to remove broadcast results. Here is this question. Now read the question, translate it into English. As if you do that, you're going to find that there's not a whole lot of math in this question. All right, guys, 80% of you are done. Let's get those answers in. Five, four, three, two, and one. Let's broadcast the results. And you can see choices A and B are very popular, as is choice D and choice C. So let's kind of look at this over here. And let's see, what is the question asking in pure English? What is the question asking? It's a yes no question. It's asking, is B greater than A? Okay, is B greater than A? That's how I look at it. Or if A is less than B. Okay, it's a yes no question. We're not asking for a value. We're not asking which is positive, which is negative. We're simply asking, is B greater than A? Okay, there's no other constraints that are given over here. So let's start solving this question. Okay, there's not much given in the question statement over here. Now let's go to statement 1. Statement 1 says, and remember we have this thing over here is b greater than a. It says absolute value uh, of a minus b is equal to b minus a, or in other words, if I were to read this properly, b minus a, which means you take a out from b, is absolute value of a number. Now, what is the smallest value of absolute value? What is the smallest value of this? B minus a, it can be 0. Okay, the smallest value of b minus a is non-negative, which means it can be 0 or it can be positive. Smallest is 0, beyond that is positive. So, which means if we say absolute value of x is y, what we can really say is y is either 0 or y is positive. Does everyone get this? When you say y is equal to absolute value of something, then you can really say y is either 0 or y is positive, or in other words, y is a non-negative number. Is that clear to everyone? Can you type that in, please? All right. So in other words, y is greater than or equal to 0, which means b minus a is greater than or equal to 0, which could lead to two inferences. Okay, which is that b is equal to a, because if b minus a is equal to 0, then b is equal to a. Or if b minus a is greater than 0, this means b is greater than a. Do you guys get these two inferences as well? Why is b a non-negative number? Because absolute value of something is always non-negative. Okay, that's why. Now b is either greater than a or b is equal to a. Can we say with 100% certainty whether b is greater than a? No, we can't say that. Why? Because there are two possibilities that exist. So hence statement 1 is not sufficient. That's your outcome from here. Okay. Is that clear? Statement 1 is not sufficient. And again, we didn't do any math over here. We just said, what does absolute value truly mean? That's all there is. It's about considering all cases. It's another process skill that you're going to see on the YouTube channel. And you're going to see many questions that talk about this. Let's go to statement 2. Statement 2 says, okay, again, remember, the question that we have to answer is b greater than a? Statement 2 says a divided by b is less than 1. Now, when you see something like this over here, when you see 0 or 1 or minus 1, okay guys, Siddharth, please put the question in the Q&A pod and you're going to really see an answer as to why that is the case. Okay, it's a good question. Please put the question in the Q&A pod. Well, I'm going to answer this over here since it's a long statement. In the last question, what we said is absolute value of z. Actually, let me just put in a notes pod. It's a good question. I'm going to go back over here. We're going to still be over here so that you guys can really see this. Pods. Let's get a notes pane. Okay. So when we say ABS of z is equal to 2, so or absolute value of z is equal to a constant k, then what, by definition, what is absolute value? Absolute value of anything is equal to up 0 or positive, regardless of what that thing is. So no, it was equal. It wasn't an equality. Okay, Siddharth, do you agree? Absolute value of anything by definition is 0 or positive. Okay, it's 0 or positive, which means when we say What is absolute value of minus 2? What is absolute value of minus 2? Plus 2. Okay. And what is absolute value of 2? That is also plus 2, right? So when we say absolute value of z is equal to 2, then you can really see why z can have a value as plus 2 as well as minus 2. Is that clear, Siddharth? Siddharth. Now let's talk about this part over here. What we are saying over here is, in the current question, in the context of the current question, and let me just explain this over here. This question is actually just the reverse of the prior question. Let's just draw a line over here. This question is saying b minus a is equal to absolute value of something. Remember this. Can you see how this question is framed or how the statement is framed? It's saying b minus a is equal to something. Absolute value of something. And as we know, this means b minus a can be either equal to 0 or, do you see the difference? Okay, good. Good. Again, we're comparing what is happening in two equations. B minus a is 0 or positive, and then we really say if b minus a is 0, then b is equal to a. If b minus a is positive, then b is greater than a. Okay. Revise the solution, you would get it. Where is the inequality sign? Here is the equality sign over here in statement 1. Here is the equality sign. There is no inequality here. There's an equal to sign over here. Now let's go to statement 2. Statement 2 says a by b is less than 1. What is 1 a symbol of? What is 1 a symbol of? Let me ask this question. It is equality, right? When you say ratio of two numbers is 1, it means they are equal. Let me just write it down. Right? Right? When you say two numbers are equal to 1, then this means those numbers are equal. I'm not asking you to look at the statement, please. I'm asking you to tell me what is plus 1 a symbol of. Right? The ratio of two numbers is equal to 1, then they are equal. Okay. Now, with that knowledge, what is this statement saying? Statement 2 is saying a by b is less than 1. In other words, what is the statement saying? A by b are not equal. A is not equal to b. A can be less than b or a can be greater than b. Okay. A can be less than B or A can be greater than B, but A cannot be equal to B. That is what you infer from this. This is pure English, not a whole lot of math, by the way. This is just reading the statements in English language. When you say A by B is less than 1, which means A by B is not equal to 1, which means A and B cannot be equal. Right? So we have two cases over here. Right? 1 means they are equal. If you say A by B is equal to 1 means A is equal to B. A could be 1,000, which means B is also 1,000. If A is 50, B is also 50. If A is minus 1, B is also minus 1. If A is minus infinity, then B is also minus infinity. What it means is that they are equal. SP says, why not multiply both sides by B wherein we get the result A is less than B? SP, do you know whether B is positive or whether B is negative? Do you know that? No. So do you know how are you going to keep the sign of inequality? Okay. But either way, you get two conditions here, which is B is greater than A or B is less than A. But essentially what you don't get is that B is equal to A. Either way, you cannot answer this question conclusively whether B is greater than A. Now let's combine these two statements. Okay. Statement 1 said B is either equal to A or B is either greater than A. Statement 2 said B is greater than A or B is less than A. Now combining these two, you get a definitive answer, which is B is greater than A, which means choice C is the correct answer. Why? You need to take both the conditions together to be sufficient. Yes, you can multiply it with B square on both sides and then you're going to still get to the same conclusion. You can multiply it with B square, you're going to get to the same answer. But do you really see how, if you read them as English, you get to answers very easily? A by B is less than 1, it means B is greater than A. How do you really say that? Let me just tell you, A by B is less than 1. Okay. So let's say A is equal to minus 2. B is equal to minus 5. Okay. What is A by B? 0.4 plus 0.4. Is that less than 1? Yes. Is A less than B? Absolutely not. B is less than A over here. Okay. Again, understand the English. That's where the process skills are important. If you multiply both sides with B square, let's do that. If you multiply both sides with B square, what you're going to get is AB is positive. If you multiply both sides by B square, what do you get? AB is positive. Right? Because AB is B square. Is less than B square. Right? And you know B square is positive. Now, let's take A is equal to minus 2. B is equal to minus 5. Then what? Okay. Do it and you're going to figure it out. Remember this, these are generic principles. Now, I want you to apply. This was the last question was a heavy conceptual question, but we learned a lot of concepts. We spent some time on it, but we learned a ton. Now I want you to apply this learning to the next question. So let's go to still solving. So take the learnings from there, where absolute value of a number is either 0 or positive. A square of a number is is always positive or 0. So let's take those constraints. Let's get to 80 people saying not solving. And then let's solve the next question. Five, four, three, two, and one. Here is your next question. Again, read the question in English. You're gonna get to the answer a lot more quickly. Right, guys, 80% of the class is done. So let's get started. 3, 2, and 1. Let me end the poll. I'm gonna broadcast the results. Now this is working. Surprisingly, I didn't realize when I entered the poll. So you can really see choice C is popular, choice A is popular, so is choice E. Let's kind of go and take a look at this. Some of you say statement 1's enough, some of you say statement um, both the statements are required. Some of you say just statement. Now, even when you combine both of them, then even then it's not sufficient. So let's kind of solve this question. What is the question asking? The question is asking, is z greater than 2? So it's a very specific question. Is z greater than 2, which means it's a 2.1, 2.2, 2.3 up to plus infinity. Okay, so that's something that we have to find. There's no constraint on z, so that's why I could really say, hey, z is 2.1, 2.2, and so on and so forth. Then let's kind of look at the first statement. So we go to the first statement. Remember, we always position what we need to figure out on the top. That way it stays in our mind. Is z greater than 2? So what the first statement says, absolute value of a square of a number is greater than 4. Okay. Now a square of any number is always non-negative, which means it's either 0 or positive, which means frankly the purpose of absolute value is not there. So we can really, the modulus or absolute value, it doesn't have any impact over here. What it really saying is that z minus 2 whole square is greater than 4. Now, there are two ways of doing it. You can either use a formula, use the a square minus b square formula, which is what I'm going to do over here, or you could just consider cases and you'd get to the same answer. So you really say essentially z minus 2 whole square is greater than 2 square. I represented 4 as 2 square, which means I added 2 square or subtracted 2 square from both sides. You get z minus 2 whole square is greater than 0, which means if you use the a square minus b square formula, what you really see is you're able to simplify this into this form, which means z minus 4, a product of two numbers, z and z minus 4 is positive, which means that either both numbers are positive, we did that in the warm-up questions, or both are negative, which means the two range of values for z is that z is negative, it's less than 0, or z is greater than 4. Now both 0 and 4 are not included over here. All right, considering that z can have two possible ranges, considering there's no constraint, can we say with 100% certainty whether z is less than greater than 2? The answer is no, we can't really say that, hence statement 1 is not sufficient. Everyone with me so far? All right, that's good. Let's carry on over here. Let's go to statement 2. Statement 2 says, yes, z can have negative values. Yes. According to statement 1, z can have negative values. Why? Because even when z has negative values, when z is minus 1, you get minus 3 square, which is absolutely, which is plus 9. Okay. Put z as minus 1 and minus 3 square is plus 9. So z can have negative values. Okay. Statement 2 says, is z greater than 2? And what we are given over here is 8x minus 4k, absolute value of something, and we don't know what x is, what k is. But what we know is that z is an absolute value of a number. Okay, so which means z is either equal to 0 or z is positive, as we already know this. So if z is equal to 0, then so essentially we can really figure out whether z is equal to 0 or z is 1 or z is 2. We can't really answer this question whether z is greater than 2. Okay, so statement 2 is not sufficient by itself. Again, there's not a lot of math over here. It's purely considering all cases. Okay, So everyone's clear with statement 2? Yes. When can you remove the modulus? Bhumika has a question. When you have a perfect square inside a modulus, or a power of 4 inside a modulus, or a power of 6, that's when you can remove the modulus. That's when it starts to become irrelevant. All right. Now, this statement 2 tells us two cases: z is positive or z is equal to 0. Statement 1 tells us that z is negative, z is less than 0, or z is greater than 4. Now, combining these two statements, what we can really say is that, hey, z is greater than 4. Why? Because this one says z is positive and this one says z is greater than 4. If z is positive, then z is greater than 4. If otherwise, and essentially the only common constraint over here is that z is greater than 4, which means both statements, when you combine them, are sufficient. All right. Okay. Where did you guys make a mistake? Let's enter your takeaways over here. Where did you guys make a mistake? And this was really not a whole lot of math. And you're combining 1 and 2. Okay. K can have any value, yes, and that's where, but whatever value K has, what you can figure out is that absolute value of a number is either going to be 0 or positive. Ignored Z is negative. That's why you chose statement 1 as sufficient. All right, that's good. Is this a 700 level question? Absolutely. This is actually a 750 level question. You took the square root. You did not make the right inferences. You did not consider all cases. You overthought about statement 2. Okay. Considering statement 1 says that z is greater than 4, if z is positive, then you can't have z is equal to 3. Okay. So you know where you faltered: combining the constraints, arriving at the constraints, uh, or just inferring what was given to you. Okay. And those of you who did not make a mistake, Arnav, that's great. I'm really glad to see that. Again, guys, we went from 500 level questions to 700 level questions, but one thing that I want to make sure that you understand with this is that even if you didn't get everything right, even if you struggle towards the end, what I want you to take away from this is, if you revise this, does this feel conquerable? Does this feel that this is something that you can do if you spend 5 to 6 more hours on it? Right? There isn't a whole lot of complex math here, right? It's about understanding and interpreting things, and which is what I want you to have as a takeaway. Uh, each one of you can get to that Q50. Now, algebra is one of the most challenging topics on GMAT. Quant geometry is actually very similar, and we'll do a session in geometry. But the thing which is there is, to be able to constantly master this, you need to have solutions which are in this particular format. All right. So 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 make sure, as you're solving questions, you focus on learning from each solution, and make sure that those questions are structured in a certain way. Why? Because essentially there's a progressive nature to this webinar that helped you understand where you're faltering, and it helped you also apply what you learned from each prior question to the next question. All right. So that's something that I want you to focus on, because if you go out and randomly start solving questions, trust me, you can spend 30 hours, you won't get anywhere. You have to do it in a structured fashion. Does GMAT have 700 plus level questions that are purely math based? Very, very, very few. In fact, so if you've, and one of the things, that's one of the things where I don't like Manhattan GMAT tests, because a lot of those tests have 700 level questions that are purely math based. On the real GMAT, such is not the case. Okay. And then again, I want to make sure that you understand that it's possible to get to that Q51 score. There's a guy who was really good at quant, but he was struggling to go beyond Q48. He's able to get to Q48, but not beyond that. Why? Because he's constantly falling in traps, and that's kind of the point that I made about blind practice. He was blindly practicing things, and again, if you do that, you keep on making the same mistakes. When he started focusing on his mistakes, when he started focusing on building these process skills where he's able to infer information that's given in the question, he's able to apply the constraints, he's able to consider all cases, where he simplified what was given to him, he realized he was making way fewer mistakes and he was constantly improving, because of which he was able to improve to a Q51. Here's another guy. We're gonna actually have him on a webinar. He's studying at Wharton right now. This guy improved from a Q45 to a Q49, and this is really important. Why? Because if you have a Q45, forget about studying at Wharton. What professors over there would not consider you to be smart enough to study over there. Now, what helped him get to a Q49? Again, the same things. You need to understand why you're making a mistake. Don't brand this as a careless mistake. You need to figure out in what kind of questions you're making a mistake. That's where the scholar name analytics helped him quite a bit. And he focused on selective practice while learning from the detailed solutions that were given to him. He got into all of these schools, by the way. Actually, he got scholarships from a few of those as well. He also got a Q for V44, which is 98 percentile on verbal. Now, again, smart kid, but was stuck at a Q45. One of the other things that I want to emphasize is, depending on where you're stuck, the recipe with regards to, hey, how are you going to move forward also changes, which is where the next story is. This guy was stuck at a Q30, which is a 20th percentile. And for him, concepts were an issue. And he started learning the basics and then moving on. And he had to focus on learning the concepts, making sure he learns the process skills, making sure he doesn't solve hard questions up front, but he focuses on easy questions first, then medium question, and then hard. And that progressive nature is what helped him improve to a Q45. And Guillermo, again, had to do both these parts where he had to learn the concepts. Q38 means that he was still at a 38th percentile, and then improving to a Q50 meant that he had to learn the concepts, he had to do the practice, he had to excel on each one of them. And again, it took longer than either one of those guys over there, but he was able to go to a Q50. What is Q50? You ask, on the GMAT, you are scored on a scale of 60 in both quant and verbal, and then your scores out of 60 are combined to get a score out of 800. So when you think about scoring a 740, you're really not saying, okay, I'm going to study, and I'm going to get to a 740. What you're really saying is, there's a certain quant score that I'm going to aim for, there's a certain verbal score that I'm going to aim for, and that would help me get to a 740. And for each one of you, there's a specific quant and a specific verbal score. This guy is also studying at Wharton right now. Okay. Now, if you need help figuring out where is it that what should be that combination of quant and verbal score, then write to me, or we do have some slots available where we help people figure their study plan out. So so we can really do that. But we do recommend that if you want a good study plan, that you actually take one of our mock tests, because in our mock test we give you your starting point. We give a very precise estimate of what your starting point is going to be. So to schedule appointment, you can visit this part over here. But before that, I'm going to give you a link as well. Because if you've taken the mock test prior to this, and they will ask you to take a mock test prior to this, because that tells you what your starting abilities are. It helps them create um, a precision study plan for each one of you. Um, take a mock test over here. Okay. So do that. Now I'm going to leave these links over here. Let's just minimize this. But what are next steps from this? What are some next steps that you can really do from here? You need to reinforce this learning. You need to make sure as you solve more questions, you don't forget these good habits. Okay. Solve the questions in the free trial if you're not a paid student. If you're a paid student, go to the linear inequalities module, start from the very beginning over there. Okay. Then solve the questions that you have in Scholaranium overall. But every question, think of learning. Don't think of speed. Think of learning. Every question that you solve, make sure that you learn from the solution over there. Okay. Also, uh, 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 if you've not signed up for our YouTube channel, we will be posting algebra questions in our YouTube channel with video solutions over there. So definitely sign up for our YouTube channel, because we'll be posting them in our community tab. You can actually see there are about 8 questions that we posted on various quant topics. There are also questions posted on leadership and so on and so forth over there. All right, with that, I want to make sure that we share the PDF with you. Here is the session PDF over here. Here is the PDF. You guys can download that. And the recording for this will also be there on our YouTube channel this evening. Okay. With that, if you want to, I'd appreciate where is the PDF? Top left corner. If you click on Algebra 2, you should be able to download the PDF. And once again, if you need help with your study plan, you can go to these links over here. Okay. Thank you very much, and have a good day. And I look forward to seeing you on e-GMAT.com. And thank you for all the words of appreciation. This really makes our day.